Welcome to solverfy.
Okay, so we're gonna start with question A. You may notice that I didn't write straight into this formula 155. You could, but I just chose for the simplicity so that we don't have to calculate numbers right away, and so that the next question will be easier, as you'll see later. Question B, part B, I mean. But yeah, so what we have to do is we have to find the average value of um, E of t squared. That's what our question tells us. For one cycle. Well, one cycle, we're told that there are 60 cycles in a second. So, so that would mean one cycle would be 1/60th of a second. So what we're going to do, so when you take an average value, you basically you integrate, you take this would be the integrand, whatever you're taking the average value of, and you take that integral for the desired time period, and then you're going to divide that by that time period afterwards. So basically, that means we have the integral from we could do any time period since it's a cycle, so long as it's 1/60th of a second long. But we'll just for simplicity we'll do from 0 to 1/60. Sorry, 1/60. And then yeah, we're taking the integral of e of t squared dt, and then in the end we're going to be dividing that. We're going to be dividing that by the time period itself. So that would mean doing 1 over, well, the time period is 1/60. So we're just going to start working with this, and we're going to put, okay, first of all, 1 over 1/60, that's of course just 60. Then we're taking this integral, and in E of t, we already defined right at the top from the question. It's A1. I chose to call it the 155 A1. So it's a sine of 120 pi t, all that squared. So what we're going to do is, before we find this definite integral, we need to find the indefinite integral. So we are going to do that separately. We're going to take the integral. That's an integral sign, non s, of, well, we can just square right now, a1 squared, and then sine squared 120 pi t, and then dt. So what we're doing is, well, first of all, you can always take a constant multiple out. In fact, I could have done that earlier, but that's fine. So I'm going to take, since a1, as I said, is a constant, it's just 155. A1 squared would be a constant, we take that out. Now from here, when we have a sine squared like this, we use this identity that I've written in green, that comes from a double angle formula, and basically we just sub that in. So our theta in this case would be 120 pi t. So that's what we're going to replace this with based on that formula. This would be we would replace that with half of 1 minus cos 2 times 120 pi t. That would be 240 pi t. Now we're going to evaluate that, and as usual, again, you can take out a constant multiple like that. So we're going to do that, and now we're going to be evaluating that integral there. So integral of 1, that's of course just t. And then the other part, we're going to have minus, and then the integral of cos is sine, but of course you also got to make sure to divide by the constant inside there. That would be that coefficient on t, 240 pi. So we're going to have 1 over 240 pi. And then sine of 240 pi t. So that would be that integral. Normally we would put an arbitrary constant for indefinite integral, but since we have a definite integral, that constant will get canceled out anyway, so I'm just not going to put that for this. And that's that. Now what we can do is we can go back to this. I'm just going to move it down so that we can work with it. This is the integral we were looking to find. And basically this would be, based on what we just found, this would be equal to the following. So we're going to have that 60, and then that integral, that's going to be, what we wrote here basically. So I'm just going to move that on. Move that here. And we're going to have that basically from the bounds 1 over 60, well, from 0 to 1 over 60. We have all those. We could take out those constant multiples though in this case too. So I'm just going to do that. We have a1 squared times half. So I'm just going to move that out. So we're just going to first sub in 1 over 60 into this part. So that gives us we can multiply the half by the 60 right now. So that would be 30a1 squared. Now we have first we're going to sub in 1 over 60. So we have 1 over 60 minus 1 over 240 pi times the sine of 240 pi times 1 over 60. So we have that, and I'm just going to move to the next line so we have space. We're going to subtract, and then we're going to sub in 0. So we're going to have 0 minus 1 over 240 pi. You might see already it's going to be 0, but yeah, 1 over 240 pi sine of 240 times pi times 0. So we have that. Now we're just going to evaluate what's inside these square brackets. So we can look at the second part first. So 0, there's 0, and then here. This 240 times pi times 0, that's 0. Sine of 0 is 0. So basically this part is 0. This entire second part is just 0. So we can cross that out. Subtracting 0 does nothing. Now we look at this first part, and we have this. And before I forget, don't forget what we're finding is the average value of the square, but we're going to have to square root that at the end because for the RMS, because the RMS is the square root of the average of the squares. So that's that. But that'll come later. Now we have 1 over 60, and then 1 over 240 pi. Fine. Now sine of 240 pi times 1 over 60. 240 over 60, that's 4. So that means we're going to have just sine of 4 pi. And that's just 0 again. So it's coming down. That would be sine of 0, which is 0. So that's 0. So we basically just have that this is equal to 30 a1 squared, where a1 is 155 in this case, times 1 over 60. 3 over 60, that's half. So basically, we have a1 squared over 2. But remember, RMS is the square root of that, so basically our RMS is going to be the square root of a1 squared over 2, and the square root of those. So the square root of those, that's going to be a1 over square root of 2. So that's helpful, but of course the final answer, we can't just have a1, some random variable that it took. So our final answer for a is a1 is 155, so 155 over square root of 2. That's the final answer. Now we will move on to question B. So that question, we are supposed to find the a value in this part, where e of t is equal to a sine 120 t, no, 120 pi t. So what we're going to do then is basically we look at what we did in part A, and the reason in the first place that I found that this was that the RMS is equal to a1 over square root of 2 is now here it's just we don't have a1. It's not called a1. It's just a, and the question asks us for a. So we found that RMS. So if RMS in that question was a1, well, in this case, for this question, our a1 is not a1, but it's a. I don't know if that's proper notation, but my point is that RMS would therefore be, in this case, a over square root of 2. In the last one, it was a1 over square root of 2. Here, it's a over square root of 2. The question says that our RMS needs to be 220. So if 220 is equal to a over square root of 2. This is very easy to solve. Multiply both sides by square root of 2. A is equal to 220 square root of 2. So that is our final answer for B, 220 square root of 2. And for part A, it was 155 over square root of 2. Those are our final answers.